right, so let's look at some of these polynomial functions of higher degree. Now in 2.1, we focused only on quadratics, so that's only a degree of 2, so that's not really large. But in our packet that we did, we were doing x to the 12th, x to the 9th, really high polynomial functions. And so that's what 2.2 focuses on, is those types of functions. So let's look at our a couple off of our worksheet and see how we did. So this one is number 9, and so if you want to pause it and get to this problem on your worksheet. But I'm just going to quickly go over what you should have been doing on this. So to start with, you had to figure out what your end behavior looked like, and so you're adding up all of your x's. So when you do that, you have 1 here, and then you've got 2, 3, and then 5 more, that's 8, and 3 more, that's 11, and 1 more, that's because we assume that's a 1 right there. So we've got an x to the 12th is what this end behavior looks like. Since that's an even power, we know it should look like kind of like a parabola does, where it starts high, a bunch of stuff going on, ends high. Okay, so if that's the case, as x is approaching infinity, y is headed upward as well, so y approaches infinity. As your x goes to negative infinity, your y is headed up here, and so it goes to positive infinity. As far as a y-intercept, we got to plug 0 in for x. And so if you do that, you'll plug 0 in for x right here, times, plug 0 in, that'd be a -5, squared is 25. And then when I plug 0 in, I'd get a -1 to the 5th power is a -1. And I could keep going with all of this, but look back here. We're multiplying by 0. Doesn't matter what those numbers are, my y-intercept is going to end up equaling 0. All right, so once you have that information, then you go back and you look at where your zeros occur. So the first one is going to occur at 0, and since that's to the 1st power, that will be a cut. And then we have a 0 at 5, and that's to the 2nd power, so that's a bounce. And then we have a 0 at 1, it's an odd power, so it'll be cut. Then at 6, it's another odd power, so it's a cut. And then at -4, it's an odd power, so it's a cut. All right, so then you go back to what your end behavior is supposed to look like. It's supposed to start high and end high. So let's see if we can make that happen. You come in here and you cut, come up and cut and bounce, and then cut. And it ended high like I wanted it to. My y-intercept matches at 0, so I'm good to go. Let's check one more. Let's look at number 10. Okay, so again, you start off with your end behavior, and you're counting up your x's. So you have 1 here, 3 more, that's 4, 3 more, that's 7, 4 more, that's 11. So it behaves like an x to the 11th. Okay, well that's an odd, so I know that it's going to look like kind of like a cubic where it starts low, bounces around a bunch, ends high. Okay, but the thing that changes that is this negative that's in front. And a lot of times we forget about that, but that negative, remember, is going to reflect this. So this actually is not going to look like this. It's going to reflect, and so it's actually going to start high, come around, bounce around a bunch, and end low. Okay, so if that's the case, as x goes towards infinity, my y is headed downward, so that goes to negative infinity. And then as x goes to negative infinity, my y is headed upward, so that goes to positive infinity. As far as a y-intercept, I'm going to have this negative, and then put in 0, so that's going to be a -2. Put in 0, that's 1 to the 3rd, so that's just a 1. Put in 0, that's going to be a -4. To the 3rd power would end up being a -64. And then the last one is a put in 0, I'd have a 6 to the 4th power, which is going to get me a 1296. All right, so when I multiply all of that together, I'm going to end up with, it's going to be a negative times a negative and another negative, so there's 3 negatives. So I know that's going to end up a negative. Multiply that all together, I get 165,888. Okay, so really low y-intercept, somewhere way down low on my y-axis. Remember, we're ignoring the y values. Okay, and that last thing I should be doing is putting in my zeros. So I have a 0 at 2. I have a 0 at -1. I have and those are both cuts because they're odd powers. And then at 4, that's another odd power. And at -6, but that's going to be an even power, so that's a bounce. All right, so then remembering what my end behavior looks like, then I'm going to be starting high and ending low here. So start high, come down and bounce, cut, 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 end low. And that's what that should look like. Okay, so let's take this to the next level then. On your packet, everything was nice and factored for you. So what do you do if it's not factored? And so that's mostly what we're going to focus on today. So when I look at this and it's not factored out, well, what's going to have to happen is I'm going to need to factor it if I can. Some of this I can do without factoring, though. I should be able to fill in this box pretty easily without factoring it, though. My end behavior. Now, if it's not factored out, you're only looking at your highest power. So my highest power is a 4. So it's going to behave like an x to the 4th. All right. However, there is a negative here, so that means my nice parabola shape is actually going to be upside down. So I'm going to actually just start low, bounce around a little bit, and come back down. Okay. So that means as x approaches infinity, y is going to negative infinity. As x approaches negative infinity, y goes to negative infinity. As far as my y-intercept, it's actually easier to do your y-intercept in this form because I just plug 0 in for x. That's all going to be 0. Plug 0 in for x. That's all 0. So my y-intercept is going to be 0. Okay, so let's go back then and let's go through. I still have to figure out those zeros. And to do that, I'm going to need to factor this thing. So let's start by pulling out a GCF. We could pull out a negative 2x squared, which gets me a positive x squared minus 1. All right, so I've got the GCF, but this is still a quadratic in parentheses, so I try to keep going. It happens to be a difference of squares, so x plus 1, x minus 1. And then I still have my negative 2x squared out here. All right, so looking at this then, I've got a 0 at 0. Okay, it's an even power, so it's going to be a bounce. I'm going to have a 0 at -1, it's going to cut, and a 0 at 1, and it's going to cut. So really tightly close graph here. All right, so we've already decided that because this is a negative on our highest power, it's going to be an upside down. So it's going to start low and end low. All right, so here I go. Start low, come up and cut, bounce, cut, back down. So there's our graph. So even if it's not factored, we can still get a graph for these. All right, let's try another one. All right, again, this is not factored, so we kind of have to go back to remembering how we do our factoring. Also on this one, we could do our end behavior. So since it's a quartic, it has a highest power of 4. It's going to start high, bounce, and end high. So my end behavior will be an x to the 4th. Y is going to approach infinity on both sides. And as far as a y-intercept, again, it's easier to put it in this format. If you plug 0 in for x, you get 0 minus 0 plus 12. So the y-intercept will be 12. All right, so let's figure out where those zeros are going to be, and we have to factor this to figure that out. So if I set up my two binomials, there's not a GCF on this one. But since it's an x to the 4th, instead of putting in an x and x, we have to put in x squared and x squared. And then I've got factors of 12. My signs are going to both be minuses, so, sorry. And then I'm going to want a 3 and a 4. That'll get me that 7 that I need. All right, and so that factors nicely, and then you got to keep going. So looking at this, I would continue with this nice difference of squares, x plus 2, x minus 2. But then this is not a difference of squares, so it's not going to work quite as nicely. Okay, so I can tell I'm going to have a 0 at 2 and at -2 on this, and they're both to the first power, so they're both cuts. Now remember that the way that I'm getting this x plus 2, I'm setting equal to 0. Subtract the 2, and that's why I know that that gets me a 0 at -2. So let's look at how you would do that with your x squared minus 3. So I'm going to do x squared minus 3 equals 0. Add the 3 over. Square root both sides. Don't forget your plus or minus. It just doesn't square root nicely. It's the square root of 3. Okay, that's not very pretty, but those are my zeros, and I would just have to approximate those on my graph. So if I plug root 3 into my calculator, it gets me approximately 1.7. So then I would put in a positive 1.7, just going to kind of stick it in there, and a negative 1.7, another closely knit graph here. Those are both going to be to the first power, so they would both be cuts. All right, then you're ready to graph. So it's a x to the 4th, starting high, ending high. So come in through here and cut, 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 and back up. And then you always check your y-intercept. My y-intercept was a positive 12, so that makes sense because I am crossing on a positive side of my axis. All right, let's try something different. So on this one, it's a cubic, so I know it'd behave like a y equals x cubed. And normally what we do when we have these polynomials that have 4 terms is we would do grouping. And the thing is once you do grouping in a little bit, you remember you're trying to get the groups to be the same. And I kind of can tell right off the bat when I try to pull out an x squared or something that this group right here isn't going to match what I have over here. I got a 12x plus 5. I'm not going to be able to do anything with that. So actually, this isn't factorable for us. And that's going to happen sometimes where you get something that you can't factor. So how do you find the zeros? Well, here's the gist of it. You can't necessarily always find the zeros, but you should be able to approximate them. So we have what we call the intermediate value theorem. And it says that if you have a and b as real numbers, such that a is smaller than b, so I put a here on the left side because it's smaller than b. Now f is a polynomial function. Now remember, our polynomial functions are these pretty bounce cut business. They just flow nicely. So what this is saying is that in the interval from a to b, f will take on every value between f of a, remember that's like your y value, so here's my y value at a, and f of b, this is my y value of b. What this is saying is that it will take on every value in between. There's not going to be any breaks, it's just going to flow nicely. Whatever it's going to do, it's going to flow without an asymptote or anything in there. All right, that's fine and dandy, but really what's important is this next part. It says what's going to happen with your y value up here at f of a and your y value here, f of b. What's going to happen for those y values for there to be a 0 between a and b? And you can see in my picture, I never crossed the x-axis, so I'm not going to have a 0. So the only way for this to get from up here to have a nice y value where it crosses and creates a 0, and then think about what the y value here is going to have to be. From up here to down here. The only way you can get from up here to down here and actually cross the x-axis to create that 0 is for this to be a positive y value and this one down here to be a negative y value, or vice versa. But to cross the x-axis, those y values have to switch between being positive and being negative. So that's what we're going to use to help us to find the zeros on this function back here that we were starting with. If I can't factor it to find them exact, I'm going to approximate them. So here's our situation. It says approximate the zeros of the function. It's the same function I just gave you. Approximate the zeros of the function, given that they're all going to fall between -5 and 5. So since it's not factorable, I'm assuming that the zeros aren't going to be pretty. I just know that it's going to cross, since it's a cubic, it should cross 3 times. Somewhere in there, they're hinting at me between -5 and 5. So what I would do with this, and you missed out if you weren't in class because we did this as a group and split up the work, but we just basically went through and made a big table and said, all right, if I plug -5 in for x, and then I'm going to go through and evaluate this function at -5. And then I put it in here, and someone found for us that that is -110. And then you put in -4 for x. And then -4 to the third, minus 2 times a -4 squared. And you're just doing this in your calculator. And we filled in this table then. And so I'm just going to go ahead and fill it in. It's your lucky day. You can just copy this. But on your test, you'll have to do this table on your own. 0, that should be an easy one to do in your head. You plug in 0 for all the x's and you get 5 back. All right. And we're just doing this in our calculator and figuring out what all the y values are that match it. So okay, so once you have this table created, and of course we're assuming here we couldn't just go graph this in our graphing calculator, because we've done that. We've done the thing where you graph it and go find the zeros, but we're assuming that we don't have access to just being able to graph it on the calculator. What I want you to recognize in here is that if this is going to somehow, think about on your graph, on your packet, here's 5 and -5, and they've told us that it's a cubic, all the zeros are going to fall between here, so I should be crossing this 3 times in here. Now it's a cubic, so I know it kind of looks like this, right? So basically what's happening is at -5, I'm way down here at -10. And at -4, I'm at -43. And at -3, I'm at -4. And all of a sudden at -2, I'm up here at 13. Well, the only way to go from this negative y value to this positive y value is to have crossed the x-axis in there, meaning that I just created a 0. So I know that there's a 0 somewhere right there. So when I look at this, what I'm noticing is it switched from a negative y value to a positive y value. And so that's my clue. There is a 0 somewhere in between these two x values. All right, let's keep going. And so then at -1, I'm still up here at 14, and at 0, I'm at 5, and oh, right here at 1, all of a sudden it slipped down here below the x-axis again because the y value is -8. So the only way for that to happen, for this to come and go from up above the x-axis to below, is to have created a 0 right there. I know that because my y value switched from positive to negative. So there's got to be a 0 somewhere between a 0 and a 1 there. All right, now I'm really not wanting to graph all of this, though I could, but really what I'm looking for is just where would those zeros fall. So that's 2 of them. Can you look at the table and figure out where the next one would have to occur? All right, hopefully you noticed right here that the y switched from negative to positive right there. So there's got to be a 0 between those two numbers. All right, so what they're asking here is for you to write or to approximate where those zeros are. So you would say something like the zeros fall between -3 and -2, between 0 and 1, and between 4 and 5. And that's just the approximating that we can do if we're not able to factor it and find exact zeros. All right, so you're going to have both types on your assignment today. You'll have some where you can factor, and then you're going to have some that are not factorable, so you have to create a table to find out where they approximately are. All right, and then the last thing that we always want to be able to kind of think through what's going on well enough that you can kind of think through this backwards as well. For instance, what if I already know what the zeros are? Could you work your way backwards into giving me the function? Normally, I give you the function and you tell me the zeros. What if it's the other way around? And so what you have to do is think back, well, if I have f of x equals, if I have a 0 at 0, you got to think of the factor that would have given that to you. If I give you a 2, what's the factor that gave that to you? Well, that one might be easier. It would just be an x minus 2. And for that negative 6, you would have had an x plus 6. So let's go back to that 0. It would have had to been an x minus or plus 0. Doesn't matter. But basically, that's just an x. And this right here, I do want you to multiply it out on this and give me a nice polynomial function like I would give you, where it's all multiplied out. So let's FOIL this together. I still have that x out in front, but if I FOIL this, I'll have an x squared. The outer is a 6x. Inner is a negative 2x, so that gives me a positive 4x. And last gets me a negative 12. And then let's just distribute that through. And so x cubed plus 4x squared minus 12x. That's your polynomial function. Now it does say in the directions that there are many possibilities. For those to be zeros, who knows what this function might have done? It might have flipped, so there might have been a negative out in front, but it still had the same zeros. There might have been a coefficient of 4 or something out front that would have stretched this graph. I'm not worried about that. I'm just going to keep, that's why they're telling you there are many possibilities, but I'm just going to keep it simple and not worry about any stretching or flipping that might have happened. I'm just going to keep the basic graph there and go with that function. All right, that's all of 2.2 on polynomial functions. Good luck.